In the second video, we'll be looking at permutations and combinations. Both of these deal with situations where we are given a group of n items and we want to select a certain number r of them. There are pretty much two different ways to do this. A permutation is the first way. A permutation is just picking a group of things when the order we pick them in matters. Or another way of thinking about it is when the position of the things matters. And then a combination is just the opposite. That's when the order does not matter. So we select a group of things, and it doesn't matter which one's first, second, or third, or what position we put them in. These both have formulas and notations that go along with them. The notation for a permutation is NPR. And what this means is that you're picking R things out of a group of n items. And the formula for that is n factorial divided by n minus r factorial. Now, if you don't remember what factorial means, or you haven't seen it before, we'll cover that on the next page. Combination has a similar formula, and the notation for it is NCR, and this means choosing R things out of a group of n things. And remember, order does not matter in a combination. And the formula to figure out this number is n factorial divided by r factorial times n minus r factorial. So just that one small difference of r factorial there. So what does that look like just really generically? Let's say we wanted to pick 3 things out of a group of 5. And let's also say that order matters. So it matters what order I pick the 3 things in. Right? There's a first thing, a second thing, and a third thing. Well, we would write this as 5p3. And the number of possible ways we can do this can be calculated using this formula. So remember, n in this case is 5, so it'll be 5 factorial over n minus r. Well, n minus r is just 5 minus 3, which is 2 factorial. And in case you don't remember what factorial is, 5 factorial just means 5 times 4 times 3 times 2 times 1. And 2 factorial just means 2 times 1. You stop once you get to 1. Well, in this case, we can see, if you kind of look at some canceling here, that, well, the 1s don't really matter, but they cancel out anyway. And 2 over 2 also cancels out to just be 1. So really, 5p3 is the same as just 5 times 4 times 3, which is just 60. If we look at this similar scenario for NCR, let's again pick 3 things out of 5. But this time, let's say order does not matter. So I'm picking 3 things, but I'm just grouping them all together. It doesn't matter which one's first, second, or third. There's no different positions. In this case, we would write it as 5c3. And the formula tells us that this would be 5 factorial over, well, r in this case is 3, so that's 3 factorial. And then n minus r factorial is again 5 minus 3, or 2 factorial. So we can go ahead and kind of do that math out. This one comes out to 5 times 4 times 3 times 2 times 1 again on the top. And on the bottom, we have 3 times 2 times 1. That's 3 factorial. And we also have times 2 times 1. That's 2 factorial. So again, we can see, well, 1 over 1 cancels out, 2 over 2 cancels out. And then we also have 3 over 3 cancels out. But the rest of this kind of stays here. Technically, we could simplify 4 over 2 to 2 over 1 if we wanted to. And this comes out as 20 over 2, or just 10 different ways to pick 3 things out of a group of 5 when the order does not matter. So you might notice that when order does matter, as in the permutation, there's generally going to be more ways of doing that than when order does not matter. So we've got a few examples to look at. In our permutation example we'll start with, you need to award prizes at a science fair. If 7 people enter, how many different ways can you award first, second, and third place prizes? So the reason this is a permutation is because we have 3 completely distinct prizes. Right? It matters who I give the first place prize to, who I give the second place, and who I give the third place prize to. So this is a permutation because the order we pick them matters. However, we're still picking just 1, 2, 3 people out of this group of 7. So this comes out as 7p3, which when you go back to our formula, would come out as 7 factorial over, well, n minus r factorial, in this case, is going to be 7 minus 3, or 4 factorial, which is 7 times 6 times 5 times 4 times 3 times 2 times 1 over 4 times 3 times 2 times 1. All of this stuff cancels out, and we're just left with 7 times 6 times 5. And if you do that math out, that comes out to be 210 different ways to award the prizes. Same exact problem here, but this time we're just going to pick 3 winners. We don't care who gets first, second, and third. They're just all winners. So this one is a combination because now there's not 3 different positions. Order does not matter. So this is 7C3. Because order doesn't matter, it's not a permutation anymore. In which case, this formula tells us that we can find the total number of arrangements by doing 7 factorial over r factorial, which is 3 factorial, times n minus r factorial, well 7 minus 3 again is 4 factorial, which if we expand that out, 7 times 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1 times 4 times 3 times 2 times 1. Now again, we have some stuff that cancels. 3, 2, and 1 all cancel out, so does this 4. You might notice that 6 over 3 times 2 is also 6, so you could cancel that. And then we're just left with 7 times 5 on the top and just a 1 on the bottom. So that's just 35 over 1, or just 35 different ways to award the prizes when order does not matter. Again, this is much less than when order did matter. Last example, 9 students want to play in the faculty versus students basketball game. If you can only select 5 students to play in the game, how many different ways can you pick the team? So I didn't tell you right off the bat if this is a permutation or a combination, but since we're not giving, it doesn't seem to be that we're assigning them positions yet, we're just selecting 5 students to play. I'm going to go with order does not matter here. Or we're just picking a group of 5 students, which makes this then a combination if order does not matter. So this is now 9C5, which, if we remember our formula, comes out to be 9 factorial over r is 5 factorial. And then n minus r factorial is 9 minus 5, or just 4 factorial. And if you do all of your math out here, 9 times 8 times 7 times 6 times 5. And on the bottom, 5 times 4 times 3 times 2 times 1 times 4 times 3 times 2 times 1. We can again do a whole lot of canceling here. 4, 3, 2, and 1 all cancel out. This 5 and this 5 cancel out. You can cancel out a 4 times 2 with an 8, leaving you with just 9 times 7 times 6 on the top, and 3 times 1 on the bottom. If you do that math out really quickly, you end up with 378 on the top over just 3 on the bottom, which comes out to 126 possible ways to pick a 5-person team out of a group of 9 students.